Hi, I'm Jessica. I will present a poster entitled The Processing and Technologies Applied to Oxidizers and Strategic Particles for Rocket Propulsion. The data presented here is part of a project developed in partnership between the Aeronautics Institute of Technology and the Institute of Aeronautics and Space. The processings presented here can be applied to components of composite solid propellants or fuel grains for hybrid propulsion. Here we have an example for solid propellants, in which the oxidizer is the main fraction applied as particles. However, metallic fuels and catalysts can also be used as powder. They are inserted in a polymeric matrix that will incorporate all particles, usually in high solid loadings. And to achieve this load, spherical particles are used and the diameters are chosen in a way that you can achieve the highest packing possible for the slurry, which is the mixture of all components before the curing. With that, we have high solid loadings, low empty spaces, and that is only possible when you have enough film of the polymeric matrix to promote fluidity. So I'm going to show 4 techniques, being 2 recrystallization techniques and 2 encapsulation. The first recrystallization technique can be applied to ammonium perchlorate, and it uses the temperature to avoid the crystallization in certain sites. Here we have the blocks representing the types of crystallization, where the blocks numbers 3 and 2 result in faceted crystals, and the number 1 represents the random crystallization, where the crystal grow in all directions, and that combined with agitation enables the surface of the crystals to be rounded, and they are amorphous, opaque crystals. The Raffling transition temperature represents the temperature after which only the random crystallization takes place. The second recrystallization technique is the crystallization in emulsion, and it can be applied to materials that melt upon the application of the temperature. The materials are inserted in a liquid medium and there is no miscibility between the pair. Temperature and agitation are used. The agitation will break the material already melted into droplets, and a sudden drop in the temperature will solidify the particles. The first encapsulation technique is the simple conservation, where the particles and a coating substance are inserted into a medium, and that will result in a coating solution where part of the material will stay in the medium and part will migrate to the surface of the particles, and the amount at the surface is either cured or solidified by controlling the temperature or adding a curing agent. The idea here is to apply a membrane around each particle with no agglomeration. The last encapsulation technique is the fluidized bed, where the particles are suspended, rotating inside the chamber, and a coating solution is sprayed on top of the particles. The solidification happens by the evaporation of the solvent. These techniques are valuable tools to promote shape modification, diameter control, or to adjust a specific property of energetic particles applied to propellant formulations. Thank you.